this is a video explanation presentation for Mission 3, in Communication Principle Assignment 2. I, Fawaz Saeed Adam, along with my teammates, Bal, Hissa, and Al-Mu'tasim Billah, will be explaining how to do the assignment, how to complete the Mission 3. So, first of all, Mission 3 talks about how converting from analog to digital. Okay, ماشي كويس. شوف shit. Hi, this is a video explanation presentation presented by me, Fawaz Saeed Adam, along with my colleagues Iqbal Hissa and Al-Mu'tasim Billah. In this video presentation, you will be able, after this video explanation. Hi, this is Hi, this is a video explanation presentation that will help you solve Mission 3 in the Ericsson Challenge. So, first of all, this is going to be presented by me, Fawaz Saeed Adam, along with Iqbal and Al-Mu'tasim Billah. In Mission 3, it will be about conversion from analog to digital. So here we're going to talk about two different ways. Pulse modulation, we're going to briefly talk about its history, types, advantages and disadvantages, and frequency range, in addition to some other topics. We're also going to be talking about multiplexing, its history, types of multiplexing, advantages, and applications of each type. So first of all, let's talk about multiplexing. What is multiplexing? Multiplexing is a device that can receive multiple input signals and give out a synchronized signal output that can be returned to its original form using a demultiplexer, which basically acts as an opposite of the multiplexer. Let's briefly talk about its history. It was first developed by Samuel Morse in the early 19th century for a telegraph system, which was made for long distance communication, and specially developed during the World Wars. And it is the set base for the modern communication system. It was further developed by Thomas Edison in 1874 by inventing a depluxing, which made it possible to transmit two messages at the same time using the same wire. Time division multiplexing was developed in the 1870s, and frequency division multiplexing was developed in 1966. Speaking of frequency division multiplexing, what is it? It is a scheme in which numerous signals with different frequencies are combined for transmission on a single line or channel. How does it work? It works by dividing the total bandwidth into different frequencies to set of bandwidth that don't overlap. And all of these bandwidths are a carrier of a different signal that generates by sending a device and are separated by one another by unused frequencies known as the guard frequencies. With the help of a multiplexer, the modulated signals are combined together, then channeled through a combined signal using a communication channel, which is a few examples of a communication channels are Ethernet, cable, telephone line, and telegraph line, allowing multiple independent data to be transmitted at the same time. And on the other end, a demultiplexer is used to convert these signals into its original form. What are the advantages of FDM? First of all, it does not require synchronization between the sending and receiving with proper operation. A large number of signals can be transported at the same time, and the process of demodulating is relatively easy. The disadvantages is that all the channels can be affected due to the wide band fading. A large number of modulated and filters are required. The communication bandwidth must be capable of handling a large bandwidth. They may be problems with crosstalk, in which there is interference between the different bandwidths, which can be a disadvantage, a huge disadvantage. Some of its applications are TV networks, FM and AM radio broadcasting, and first generation cellular telephones. Here we can see how it works. We have 3 different senders, and using a multiplexer, we can see the channels and the guard bands between them. Then using a demultiplexer, we can see how the channels can be divided and we can receive the data. Now moving to time division multiplexing. It is a method of transmitting and receiving multiple independent signals over a signal transmission channel. So, as you can see here, there is only one channel that's transporting all the different signals. So there are 2 different types of TDM, or time. First of all is synchronous multiplexer. It allows signal multiplexer. There are 2 types of time division multiplexers. The first is synchronous time division multiplexer and asynchronous time division multiplexer. Synchronous time division multiplexer allocates the same time slots to each device without considering the fact that the device contains data or not, resulting in a number of slots in the inputs being equal to the number of lines. Thus may result in empty occupied slots, since the time slots are predefined, and as a result the usage of the device is less. While statistical or asynchronous TDM does not allocate the same time to each device without considering the fact that the device contains data or not, resulting in less number of slots per frame than the input lines, resulting in the number of time slots are always based on the statistical analysis. Thus, the total speed of the input can be greater than the capacity of path, and as a result the usage of the device is more. Some of the applications are in digital audio mixing systems, cellular radio, satellite access systems, and more. Finally, let's talk about the disadvantages and advantages of TDM. The disadvantages is that it requires usually less hardware, it's less complex than FDM, and it is more efficient than FDM, and there is no distillation as a result. Its disadvantages is that it needs synchronization, it has less latency than FDM, and addresses information and buffer is needed. So this is my part, and thank you. Now, moving on to my teammate. الله طويلة 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 يا ابوي، طويلة طويلة.